Hey everyone, and welcome. Today we're tackling a Leetcode problem called Keep Multiplying Found Values by 2. It sounds a little strange, but it's a great exercise in how to search for data efficiently. We'll break it down step by step and look at a couple of clever ways to solve it. Let's get started. Alright, here's the official problem description. The main idea is that we're given a list of numbers, which is called nums, and a starting number, called original. Our job is to follow a simple rule. If our current number is in the list, we have to double it. Then, we take that new doubled number and check again. We keep doing this. Find it, double it, find it, double it, until we have a number that isn't in the list. That final number is our answer. Let's walk through the first example to make this crystal clear. We start with the number 3. Is 3 in our list? Yep, it's right there. So we double it. 3 times 2 is 6. Now, our new number to search for is 6. We look through the list again, and we find it. Great, so we double it again. 6 times 2 is 12. Okay, next up is 12. Is 12 in the list? Yes, it is. So we double it one more time, which gives us 24. Finally, we check for 24. Looking through the list. Nope, no 24. Since we couldn't find it, the process stops, and we return our final number, which is 24. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. The logic applies everywhere, and I'll be showing the full code for Java, C++, and JavaScript towards the end of the video. So the most straightforward idea is to just do what we did in the example. Take a number, scan the whole list, and if we find it, double it and repeat. But scanning the whole list every single time feels a bit inefficient, right? A better way is to sort the list first. Once the numbers are in order, we don't have to jump all over the place. We can just walk through the sorted list one time, checking for our number as we go. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first. And don't worry, after that, we'll walk through it together. Alright, here's the code for our sorting approach. First, you can see we call the sort method on our list nums. This puts all the numbers in ascending order. Then, we start a simple loop that goes through each number in the now sorted list. Inside the loop, we just have one check. Does the number we're currently looking at equal our original value? If it's a match, we just double original right then and there. Because the list is sorted, this works perfectly. After the loop finishes checking all the numbers, whatever value original holds is our final answer, so we return it. Okay, that sorting method is pretty good, but can we do even better? The main bottleneck is still the searching part. What if we could make that searching part? Well, almost instant. This is where a hash set comes in. Think of it like a directory or an index for our numbers. We can spend a little time up front to put all our numbers into this set. The payoff is huge. After that, checking if any number exists in the set is super fast, practically instantaneous. And here is the code using a hash set. It's really clean and elegant. First, we create a new set, which we'll call S, directly from our list of numbers. This one line does all the work of building our fast lookup directory. Then, we use a while loop. This loop's condition is really simple and readable. It just says, as long as our original number is in the set. If it is, we go into the loop and multiply original by 2. Then the loop checks again with the new number. The moment it checks for a number that isn't in the set, the loop stops, and we just return the final original value. So let's compare these two solutions. The sorting approach has a time complexity of order n log n. That's because the most expensive part is the initial sort. The space it uses is usually pretty small, just what the sorting algorithm needs internally. The hash set approach has a time complexity of order n. This is faster. We just have to go through the list once to build the set. The trade-off is space. It has a space complexity of order n, because in the worst case, we might have to store every single number from the input list in our new set. So, it's a classic time versus memory trade-off. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java using a hash set. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution, using an unordered set. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript, using a set. Hopefully seeing it in a few different languages helps solidify the concepts. So let's quickly recap. We looked at a problem that's all about searching for a value over and over again. The first approach used sorting, which is a solid technique that makes searching much more efficient than just scanning a messy list. The second, and slightly faster approach, used a hash set. This highlights a really common pattern in programming. You can often make your code run faster if you're willing to use a bit more memory. Choosing the right data structure makes all the difference. Alright, before we wrap up, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with a little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads, and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.